What if everything you know about time, space, and reality suddenly stopped making sense? Imagine floating through space, completely alone, nothing around you except darkness. Far ahead, you notice something impossible. A giant, perfectly black circle. It doesn't shine. It doesn't reflect light. It simply swallows everything. This is a black hole, the most mysterious object in the universe. But here's the terrifying question. What actually happens if you fall inside? Would you die instantly? Would your body be stretched apart? Could you survive? Could you travel through time? Or could you enter another universe? The truth is even stranger than science fiction. Because according to modern physics, once you cross a certain invisible line, there is no way back. Not even light, the fastest thing in the universe, has. And yet, scientists still argue about what truly happens beyond that point. Some believe you'll be torn into atoms. Others believe you'll never even notice crossing the edge. And a few believe something even more impossible. Today, we're going on a journey to the edge of reality itself, a place where space bends, time slows, and the laws of physics begin to break. Welcome to Unknown Universe. Black holes are everywhere. Some are only a few times heavier than our sun. Others are monsters, millions or even billions of times more massive. Right now, our own galaxy, the Milky Way, has a supermassive black hole hiding at its center. It is silently controlling the motion of millions of stars, including our own sun. For hundreds of years, people imagined black holes as cosmic monsters, bottomless pits, doors to hell, places where the universe simply ends. But modern science tells a much stranger story. Black holes are not holes. They are objects, real objects, made from collapsed stars. So dense that gravity becomes almost impossible to escape. Everything nearby is forced toward them. Even light cannot escape. That is why they appear completely black. Yet, despite decades of research, no human will ever be able to visit one, because the closest known black holes are unimaginably far away. Everything we know comes from mathematics, computer simulations, and the strange predictions of Einstein's theories. So, if no one has ever fallen into one, how do scientists know what would happen? That's exactly the mystery we're about to explore. Long before telescopes became powerful, people wondered if gravity had limits. Could something become so heavy that nothing could escape? It sounded impossible. Then, in the early 1900s, one man completely changed our understanding of the universe: Albert Einstein. His theory of general relativity revealed something extraordinary. Gravity isn't an invisible force pulling objects together. Instead, mass bends space itself. Imagine placing a heavy bowling ball on a stretched rubber sheet. The sheet bends. Now place a marble nearby. The marble rolls inward, not because the bowling ball pulled it, but because the surface itself changed. The universe behaves in a similar way. Stars bend space. Planets follow those curves. Even light must follow the shape of space. This explains something unbelievable. If enough matter were squeezed into one tiny point, space could bend forever, creating an object with gravity so powerful that escape becomes impossible. At first, even Einstein doubted such objects could exist. Many scientists believed nature would somehow prevent them, but the universe had other plans. Every star is fighting a silent battle. For millions, sometimes billions of years, gravity pulls inward. At the same time, nuclear explosions inside the star push outward. As long as those forces remain balanced, the star survives. But nothing lasts forever. Eventually, the star runs out of fuel. The outward pressure disappears. Gravity wins. In just seconds, the entire star collapses inward. The explosion that follows can outshine an entire galaxy. A supernova. The remaining core is heavy enough. Nothing can stop the collapse. Not atoms, not molecules, not even the particles inside atoms. Everything is crushed closer and closer and closer until an extraordinary object is born, a black hole. Around it forms an invisible boundary called the event horizon. Cross that line, and every possible path leads only one direction: inward. There are no exits, no second chances, no rescue missions, only darkness. And the most frightening part? The event horizon is completely invisible. You would never know the exact moment you crossed it. In part 2, we'll cross the event horizon. We'll discover what happens to your body, why time almost stops, what spaghettification really means, and why someone watching from Earth would see a completely different reality than you. Because once you fall toward a black hole, the universe never looks the same again. There is no loud alarm, no warning light, no countdown. Everything appears almost normal. The stars are still there. The silence of space remains. Your heartbeat is the only sound you hear. Then, without realizing it, you cross the event horizon. The point of no return. Surprisingly, you don't feel anything. No impact, no sudden explosion, no invisible wall, just silence. But from this moment, every road through space leads deeper into the black hole. There is no turning around. Not because your spaceship is too slow, because the universe itself no longer offers a path back. Now something impossible begins to happen. Time itself starts changing. According to Einstein's theory, gravity doesn't only bend space, it also bends time. The stronger the gravity, the slower time moves. Imagine two identical clocks. One stays safely on Earth. The other travels close to a black hole. When both clocks are compared, they no longer agree. The clock near the black hole has ticked more slowly. This is called time dilation. It isn't science fiction. It has been measured around Earth using satellites. Near a black hole, the effect becomes extreme. To you, everything feels normal. Your watch keeps ticking. Your breathing stays the same. But for someone watching from far away, your time slows almost to a stop. Imagine scientists on Earth watching your journey through a giant telescope. They see you getting closer and closer to the event horizon. Then, something strange happens. You begin to slow down. More and more and more. Eventually, you appear frozen in place. You never seem to cross the edge. Your image grows darker, redder, fainter, until you simply disappear. Not because you escaped, but because the light coming from you becomes weaker and weaker. To Earth, it looks as if you are trapped forever on the edge of the black hole. But your experience is completely different. To you crossed the boundary long ago. This is one of the strangest predictions in modern physics. Two observers watching the same event, yet witnessing two completely different realities. Now comes the part most people fear. Gravity is not equally strong everywhere. The closer you get, the stronger it becomes. Imagine your feet are slightly closer to the black hole than your head. Your feet are pulled harder. Your head, a little less. This difference is called tidal force. At first, it is small. Then, it becomes unstoppable. Your body begins to stretch. Longer, and thinner. Bones, muscles, organs, every cell pulled apart. Scientists have given this terrifying process an almost funny name: spaghettification. Your body would become thinner than a strand of spaghetti before being torn apart completely. Not by heat, not by an explosion, but by gravity itself. Gravity becomes the ultimate force. But here's something surprising. Not every black hole would destroy you immediately. A small black hole is incredibly dangerous. Its gravity changes so rapidly that spaghettification could happen before you even reach the event horizon. You would never make it inside. But a supermassive black hole, the kind found at the center of galaxies, is different.
For a short time,
horizon is
you might
enormous.
still be alive.
The change in gravity
Still
at the
thinking.
edge is much gentler.
Still looking out the window.
You could actually cross the event
Completely
horizon
unaware
without feeling
that
anything
escape
unusual.
has already become impossible.
That idea may be even more frightening than instant death. Because beyond the event horizon, there is no map, no photographs, no returning messages, only theories. In part 3, we'll explore what might exist at the very center of a black hole. Could it contain a portal to another universe? A wormhole? The end of time itself? Or something that completely rewrites everything we know about reality? The greatest mystery is still waiting. If you continue falling, there is only one destination left: the center. The place scientists call the singularity. According to Einstein's equations, This is where space becomes infinitely curved. Gravity becomes infinitely strong. Density becomes infinite. And the laws of physics simply break. Imagine trying to divide a number again and again and again until mathematics itself stops making sense. That is what happens here. Our best theories can no longer describe reality. It is as if the universe reaches a page that has never been written.
No scientist knows what truly exists at the singularity because every equation fails.
The first theory is the simplest and perhaps the most terrifying. You fall forever until every atom in your body is crushed beyond recognition. There is no escape, no afterlife inside the black hole, no hidden world. Only the complete destruction of everything that made you, you. According to this idea, the singularity is the final destination, the ultimate dead end. If this is true, every object that has ever fallen into a black hole still exists there, compressed into a place smaller than imagination itself. But what if a black hole is not the end? What if it is a doorway? Some physicists have imagined something called a wormhole, a shortcut through space and time. Instead of ending your journey, the black hole could connect two distant parts of the universe, or perhaps another universe entirely. Imagine entering a tunnel near one galaxy and emerging millions of light years away, almost instantly. It sounds impossible. Yet the mathematics of general relativity allows such ideas under very special conditions. The problem? No one has ever found a real wormhole. And even if one existed, it might collapse before anything could pass through it. For now, it remains one of the greatest mysteries in physics. Now comes a question that has puzzled the world's greatest minds. What happens to information? Imagine throwing a book into a black hole. The pages disappear. The words disappear. The ink disappears. But according to quantum physics, information can never truly be destroyed. So where does it go? This mystery became known as the black hole information paradox. Some scientists believe the information is somehow stored on the event horizon. Others think it slowly escapes over unimaginable lengths of time through something called Hawking radiation. And some believe our understanding of reality is still incomplete. Even today, this question remains unanswered. One mystery has challenged generations. Perhaps the most incredible part of this story is not the black hole itself. It is what it reveals about us. Every answer we discover creates even more questions. What is space? What is time? Why does gravity exist? Can two completely different theories of physics ever become one? Black holes sit at the edge between what we know and what we have yet to understand. They are not just objects in space. They are laboratories where the universe tests its own rules. So, what happens if you fall into a black hole? The honest answer is astonishing. No one knows. We understand the journey. We understand the event horizon. We understand how gravity twists space and time. But beyond that point, the universe keeps its greatest secret. Maybe there is only darkness. Maybe there is an ending beyond imagination. Or maybe there is a reality waiting to be discovered. Pause. Until that day comes, black holes will remain the greatest mystery in the cosmos. A place where science meets the unknown, where certainty ends and curiosity begins. The universe does not owe us answers, but it always gives us another mystery to chase. Some doors can only be crossed once. Thanks for watching Unknown Universe.